Okay, hey there, we've got a Codeforces Round today. It is round 719 div 3. Okay. Oh, I got logged out of something. Come on. Return to the previous task. Oh, I'm just gonna do this. Okay. I see. So it's basically set to log in the middle of the contest. minus AI equals J minus IC. Okay, let's. String so that I can. Right, and now we can just sort them. And then now we just equal. Wait. Oh, right. What? mean, it's just a search. I guess I can just do F1 first. It always exists. What? Oh, damn. What does that mean? No, that's not what it means. It's the last position. Why does it keep checking this? Well, oh, you just solve the whole array? I mean, you can't solve the whole array. just solve the whole array. It's too annoying, but what if you... Basically, if you ever repeat a query, so wait. So we're saving the sum, right? So then save n is going to be sum minus. No, that's not right. Oh, I forgot to update. Okay, so if you use a portal, then you go to the. You just use one. So one option is the direct travel distance, the other option is the closest portal. Extra. This is also kind of a good purpose. Yeah, this is. I'll just do it. Hold hands. And then okay, so oh, I see. So you got wrong answer on test 1. That doesn't give a penalty. All right, here's the standings. Excuse me, I have both submitted G, and actually geothermal also submitted G a good time ago, but it's still running. John also submitted G. Yeah, so actually, what is geothermal's time? 55 minus 20, right? Okay, so geothermal can definitely still pass me, so assuming I get this, I think I'm only guaranteed third. So anyway, it'll take a little while to run. In the meantime, we can talk about the solution ideas, and I'll probably just go over them pretty quickly. So, all right, so for this problem A, we're just trying to make sure that there are no, there's no character that shows up in this string that isn't all contiguous. So, for example, this string is fine because all the Z's are together, all the F's are together, all the G's are together. There's only one G. Same for the Y. We're good. But this string is bad because there's B's here and there are B's here. So because n is so small, you could just loop over all pairs, I guess, and just check if there's a pair that's equal with something not equal in between. And actually that would be cubic runtime, but that's actually fine. What I did is I read the string and then I took the sorted version of the string and then I just ran unique on both. Unique is a built-in C++ function, and basically it's it would compress, this string down to A, B, C, D, E, B, C, right? And with the sorted version, you'll get one fewer B, and so you'll know that it's different. And so pretty simple, just check the sizes. All right, problem B. I actually did this one first. Right, so we're counting the number of ordinary numbers between 1 and n. Ordinary means all the digits are the same. Yeah, so all I did is just start with a number and then loop over the number of digits, loop over the value of the digits, and then I just use this. So I built a string with a number and then converted it to an integer, and I only count it if it's unless it equals to n. I guess this is mad at me because technically I should be doing this. And that's it. Problem C, you need to construct a matrix where an n by n matrix of numbers from 1 to n squared, where there are no adjacent numbers, like adjacent squares in the matrix that have values that differ by exactly 1. And then you print -1 if it does not exist. So it turns out for 2 it does not exist, but for every other number it exists. What I did is I just filled in the matrix. So I just start with the odd numbers. So I go 1, right here. I go 1, 3, 5, 7, 9, and then I just start going with the even numbers from there. 2, 4, 6, 8. And so if n is 4, it'll be 1, 3, 5, 7, 9, 11, 13, 15, 2, 4, 6, 8, 10, 12, 13, 16. And the reason that nothing will be adjacent is, so essentially for any horizontal adjacent pair, their difference is pretty much always going to be 2, except for the case of the biggest odd number and the smallest even number. And if n is at least 3, then we know that the difference between those is more than 1. And then for any vertically adjacent, yeah, basically again the difference will be much bigger than 1. The only case we kind of have to worry about is when we have an odd number on top and an even number on the bottom. But yeah, in that case, basically the odd number should be much larger than the even number. We really only have to worry about the 2 in particular, because for example 9 and 2 here, if we go 1 to the right of the 2, we'll have 11 and 4, the difference will be the same. And yeah, it turns out the difference is smallest when n equals 3, and the difference is 3, and so that's fine. As n gets bigger, the difference gets bigger. There are probably other ways to do it, but that was basically what I did here. Let's check the standings. Still running. Let's see. Okay, so geothermal ends up with 84 penalty. I guess I end up with 86 penalty. Okay, so I think I'm in 3rd. Okay, so problem D. Right, so we want to look for aj minus ai equals j minus I. We can just rearrange this. It turns out to be aj minus j equals ai minus I. And then that becomes a much easier problem to deal with. We're just counting the number of pairs whose ai minus I value is equal. And yeah, I just used a map for this. So I just do ai minus I and add that frequency and then increment it. Just remember to use 64-bit integer. So that's D. E, yeah, so E is a classic problem. So we have a bunch of sheep in a string, which are the stars, and we want to move them so they're all adjacent to each other. So for example, something like this, we want the min number of moves to do that. And the idea here is, in order to make, first of all, let's say we picked the location we want to move them to. Well, we should move the first sheep to the first location, the second sheep to the second location, and so on, the third sheep to the third location. And you can prove that with a simple swapping argument. If you have something out of order and you swap it, it can only decrease the cost or keep it the same. It can't make it worse. So once we know that, then instead of moving them to consecutive points, what we can do is we can just take the location of the sheep. Right, so here it's 0, 1, and 3. And then if we're considering moving 0, 1, and 3 to, in this case, 2, 3, and 4, what we could do instead is we could subtract the sheep index from each location. So instead of 0, 1, and 3, we can just do, basically we do sheep I minus I. Sheep I minus I. And the reason we do that is once we have that, we know that we're going to, instead of putting them in consecutive locations 2, 3, 4, we can just put them all in the same location 2. So in this case, now we have this new problem where we have this array and we want to make every value equal. And we want to do that with the min number of moves. And this is a well-known problem. You just take the median and you move everything to the median. And so that's just what I do here. I sort and then I calculate the median and add up the absolute values, s minus median, and then that's the answer. Yeah, and then I guess again, make sure to use int64 here. Okay. Okay, so problem F. So this first version is really simple. We're just going to do a binary search. In terms of this query, it turns out we only need to query prefixes. We just want to find the kth 0, we want to find the, basically the last prefix with, if we're using 1 based for k, we want to find the last prefix with less than k zeros. And that gives us our location. And so each query, or like the first query would be log n steps, and they give you 20, and that's really fine. And so that's what I'm doing here. So the funny thing is I'm always querying from 0. And then to solve the kind of upgraded version, notice that after each query they only change one thing, which is replacing the 0 you found with a 1. And that way you can kind of just cache the queries you've done. So I just save them here. And if we've saved one, then all we need to do is kind of add all the things that have changed to a 1 in the meantime. So when I do a query, I save it along with subtracting out the number of 1s that have shown up before the query. And then when I get a new query that is a repeat, I can just pull out the saved version and then add the number of 1s. So that's why I have this fenwick tree, helps me track the number of 1s. And then I just make sure that every time there is an update that I add a +1 there. Yeah, I guess I don't have a, well, in terms of a proof, so basically if we think about this binary search, it ends up being like a binary tree where you have like the midpoint of the whole thing, and then you branch out into the 1/4 and 3/4 points and so on. And yeah, I think essentially, you can just show a lower bound or an upper bound where any of the higher levels of the tree can be fully saturated, and that has a relatively low limit because there aren't as many nodes. And then in the bottom layers of the tree, where there are a lot of nodes, each layer can only have essentially t different nodes queried, because each query can only query 1 node per layer. So yeah, we should be quite a bit under 6 times 10 to the 4th. I think it's I guess we just find the first power of 2 that exceeds 10 to the 4th, which should be 14. So yeah, we're essentially just adding up I guess n equals 2 times 10 to the 5th, and then is it push? It's append, is it? Okay. Yeah, so those are the levels, and then we're just doing we're essentially just doing this. Oh wow. Is that too many? Oh, but it's not. Oh, this isn't quite right actually, because right. I think we shouldn't have this. So I think levels should actually be. Right, this should add up to about 200k. And then now we're doing this. So we're doing, yeah, this is our worst case. Okay, So this should be good. That's pretty tight though. I'm surprised that they didn't give you a little bit extra. But anyway, I think that's fine. G is still not done running. I wonder why this is so slow. 100. Telion test 72. Wow. Okay, and finally problem G. So we want to go from home to school. Basically, there are two ways we can do it. One is we can just use no portals and just walk there, and that's a pretty simple BFS. Oh, I see. This grid has 4 million things in it. Are they trying to break? I guess they're trying to prevent you from doing Dijkstra. You just have to do BFS. It's a little weird, but okay. Yeah. So one way is you just go straight there, and so that's just a BFS. Just BFS from 0, 0, find the distance to n minus 1, n minus 1. And then that would be multiplied by w. And then the other thing you can do is you can take portals. And portals let you go from one portal to another portal. The cost is the sum of the portal costs. Yeah, so basically the claim here is if you use a portal ever, you should only use it once. Because imagine if you used it twice. First you went from portal A to portal B, then you went from portal C to portal D, and B and C might be equal, it doesn't really matter. Well, you would rather just go from portal A straight to portal D in that case. So we can just compress all those into a single portal jump. And then because we can compress that, then we can just solve each side independently. What's the cheapest way to get from the start to a portal, and what's the cheapest way to get from the end to a portal? So we just do one BFS from the start, and then one BFS from the end, and that gives us the source best is the cheapest portal for the start, target best is the cheapest portal for the end, and then source plus target is another option, and that gives us the answer. Okay, so yeah, that is all the problems from this round. I don't know why this is so slow, but all right, I don't think I'm going to wait for this to finish, so I'm just going to assume it passes and then close out the video here. So thanks for checking it out, and I will see you in the next video.